Hey guys, welcome back to the channel. Today we're going to do a build with these Hengtai 46135 cells here that I got from batteryhookup.com. It's a LiFePO4, 25 amp hour, and so that's 80 watt hours. So we're going to build an 8S 1P setup, so get us 24 volts. I have a particular application I want to use for this, but you know, it could be 4S, it could be 8S, it could be as big as you want. Each cell comes with a grouping connector here that has male and female protrusions on it, so you can make packs very quickly and very easily. I've already made up my 8S, and I've got 2 of them. So every cell comes with one of these, and then you also get a bus bar and I believe an M6 nut. And so let's go ahead and put the 8S pack together. This is going to be a fairly quick build because that's the idea. It's meant to be really easy. All right, the pack is built. These connections, these frames, this building blocks, whatever you want to call them, they are a little loose. So it can be a little finicky to get everything lined up and supported. They do have these pass-throughs, so you can actually run a threaded rod and some bolts and some nuts on there to, you know, compress it together, not for protection, but mainly just to keep it as one piece. Technically, I don't need that for what I'm going to do with the enclosure. Matter of fact, I probably didn't even need this framework in order to do that, but it's good to have it. It's now kind of one solid pack now that I've got all the bus bars and the nuts on. So next, I want to go ahead and show you my 3D print enclosure, and then we'll put this together and start wiring up BMS and get that much closer to being done. All right, we've got our enclosure 3D printed. Turned out pretty good. Got a little bit of banding up here at the top, and I'm guessing that was just some wobble that the system couldn't compensate for something being this tall. But we've got our slots here for the studs to go through, and so this will be nice and secure. It should not shift around that much. So after the cells go in, we have the BMS sled. So this has the BMS already connected through the mount holes that I had modeled. Here we have a pass-through for the battery negative to come up and connect there, and then the battery positive will come up here, so the load will be these 2 wires. The slot here is for the trace leads here to go to each cell group. And then there'll also be some thermal wires that can run through. The screen also connects, and this does have a screen, which takes us to the top piece. Top piece here, we have some semi-flush banana connectors, which can handle up to about 15 amps, which is more than enough for my application. I got a center cutout here for the JK-BMS screen. JK-BMS is becoming one of my favorites to work with. The screen gives really good diagnostic information, which you'll see, but I love that it has the power button, so you can turn the entire system on and off, either through the app, Bluetooth-wise, or through this. And so let's go ahead and attach our leads and get the battery one step closer to being assembled. All right, we got the battery built here. I went ahead and ran the BMS wires and the thermals and gave myself some work on the positive, negative terminals. It was kind of cool. I was able to use the cavity that the threaded bolts would go through to get the wires to kind of go in and out through the zigzag and just all come out at this one spot, which will match the BMS sled. I did make a tweak to that, and I'll show you in a second, but let's go ahead and get it in the box and make sure that none of the one of the terminal rings have added too much extension to these bolts for it to fit correctly. I might have to tweak that. I hope not, but let's go ahead and get that in there and then go from there. All right, I added some fabric tape around the whole cell pack and then made some looped ends so I can, so they're not sticky. So I could use these as pull tabs if I need to get this out of the battery enclosure, because it's going to be a tight fit, and so I'm going to probably need some leverage to get it out of there. And so let's go ahead and get it in the box and make sure everything fits. All right, that's a little disappointing. The width needs to be adjusted by millimeters. It's hard to calculate how deep this stud would be once these bolts are on, especially the ones with the terminal rings. There's just very little left. And if I forced it in there, I think this is just going to bow out, and I don't want that. So I'm going to reprint this, but I am going to go ahead and take the time to go ahead and make the bottom a lid, or, very similar to the top. Just make that a lid so I can take it on and off. And I may give myself a little more margins so that it's a smoother fit. So that's going to take a long print. So I'm going to go ahead and redesign that and come back to you on that one. All right, we got our case reprinted. Now it's just a shell. We have a bottom and a top lid and our BMS sled. So I extended this wire a little bit longer, and the reason I have two of these off of the positive is instead of doing a parallel, I'm going to do one to each. That way the load is equal, so I can do 15 amps and not put 30 amps on a single wire, even though this thickness of wire should be able to handle 30 amps, no problem. And then off of the BMS will be these two. Let's go ahead and put it together. Now that we've added that little bit of clearance, cells working in there quite nicely, and it's pretty stable. So now I'm going to go ahead and put the sled in, and I'll probably use a little bit of super glue just to kind of in the corners, just to make it, it's still there, but it does move around a little bit more than I used to when I took that margin out, or that clearance. But we'll go ahead and put that in, and then start wiring up the BMS. All right, we've got the sled in place and the BMS hooked up, and I've tested the app, and it's connecting. But I did miscalculate on the depth I needed here with the lid and those terminal plugs. So I'm printing just a little bit of an extension of this. It'll be just like this, but shorter. This is a test piece I did earlier. It's just too long. So I'm going to go ahead and maybe do a 15 millimeters and then adjust my model. It's just not worth reprinting this whole case. It's, quite a bit of filament, but it's an easy fix. And so once that's done, we'll button it up for good and do some capacity tests. All right, last look before we seal it up. I have super glued this extension on. It gives me the depth I need for these terminals and such to have room. I'm going to use really long screws here to make sure there's also a physical connection between here and here. And so let's go ahead and box it up, and then we'll get to our capacity test. All right, capacity time. We've got the battery over here on the left. I get a little off screen, and there on the left we have a coulometer that will take care of measuring the amp hours. I have it set at 100 amp hours, so if it goes over the 25 that it's rated for, we'll kind of know where it ends up being. And then it's connected to this variable power supply right here. And so the best thing I found to kind of handle high current discharges that is consistent is to charge another battery that's lower in voltage but higher in capacity, so that the pack on the left will fully give out all of its power in a very consistent manner. So on the variable power supply, we've got it set up to 14.4 volts at 10 amps. And that should theoretically pull 5 amps off of the battery pack. And since there's 25 amp hours, theoretically, we should take about 5 hours to do this test. And so let's kick it off, and then we'll come back and see the results. All right, test is complete. I actually ran it twice to make sure I got the same results both times. And within the margin of error, I got roughly 25 amp hours. A little bit less here in this test, so it's 24.4. But again, I think that's within the margin of error of measuring tools and so forth. So I think the cells live up to their advertisement. It works really well. So let me show you what I have designated this battery pack for, and then we'll call this a video. All right, here's the application for this particular battery. I've got this 12 volt / 24 volt cooler, and 24 volts, you don't need as much wire to get the same amperage. So this battery is designated for this purpose, even though I can use it for other things, but this is why I created it. If you have any interest in the cells, the cooler here, anything that I bought for this project, I will have a link in the description. And thanks guys for watching. See you on the next one.